Hi, and welcome. In the last section, we learned about asynchronous I/O and coroutines. In this section, we're turning our attention toward metaprogramming and programmable syntax. We're going to look at various ways Python allows us to control or alter the meaning of syntactic elements and how to use those features beneficially. Metaprogramming is a blanket term for techniques where programs use program code or data structures constructed directly from program code as data to be manipulated. Python has a number of different features that can be thought of as metaprogramming, and in this video we're going to look at one of the most ubiquitous function decorators. We'll see how to construct a decorator, how to use it, and how it works. The basic definition of a decorator is simple. It's just a function that takes another function as its input, does something with it, and then returns the result of its operations. The return value replaces the original input function, so the changes a decorator can make are potentially quite drastic. A decorator that doesn't change anything at all is a function that accepts one parameter and immediately returns it. Python has a special syntax for applying a decorator to a function using an @the-rate syntax. Using this syntax, we just write an @the-rate symbol followed by an expression that evaluates to a decorator function. We put that on the line right before the definition of the function we want to decorate. This syntax means as soon as we're done defining the function, call the decorator function on it, and then assign the return value of the decorator to the variable that would have contained the function. Python includes a few decorators in the global namespace and an expanding list of them in the standard library. The most commonly used global decorator is static method, which makes a class member function be callable through the class rather than through an instance, just like static methods in other languages. It's also possible to use multiple @the-rate lines before a def, in which case multiple decorators will be invoked. The decorator that's closest to the def will be called first. Then its return value will be passed in to the next closest decorator, and so on. Eventually, the return value of the topmost decorator will be assigned to the function's name in the containing scope. One of the most common uses for decorators, in fact, the reason they're called decorators, is to add attributes to function objects. These attributes can be used by code in other parts of the program to distinguish decorated functions from each other and from undecorated functions. This is easy to do. Inside the decorator, we assign the attributes to the function just like we would for any other object, and then we return it. Then, elsewhere in our code, we could check for the attribute and respond accordingly. That's all well and good, and often quite useful, but we could do a lot more with decorators. For example, we could enclose the function in a wrapper that performs some computation before or after calling the function. To do this, we want to define the wrapper inside the decorator. If you haven't seen this before, it means exactly what it looks like. The definition of the wrapper function is actually inside of ints only. So, when ints only is called, it defines and then returns a wrapper function. Each time ints only is called, it defines a new wrapper function. When a function is defined inside another function, the containing function's local variables remain available to the inner function. In this case, the wrapper does some manipulation of the function arguments and then calls the wrapped function and returns its results. We imported and used a decorator called wraps in the last example. The wraps decorator's job is pretty straightforward. It makes the wrapper look like the wrapped function to tools like PyDoc. However, wraps took a parameter. How does that work if a decorator always accepts just one parameter? And that's the function it's being applied to. The key is that the @ symbol isn't followed by the name of a decorator per se. It's followed by an expression that evaluates to a decorator. So, wraps isn't actually a decorator. Strictly speaking, it's a function that returns a decorator. When Python evaluates the function call expression, wraps returns a decorator function, which is then applied to our wrapper. If we wanted to modify our ints only decorator so that we could specify an arbitrary function that would be applied to all the parameters, it would look like this example. So now we have a function called only, which returns a decorator, which in turn returns a wrapper, which calls the original function. That might look terribly inefficient, but in fact, the only overhead comes from invoking the wrapper each time we call the function. The outer two layers of code only run once when the function is defined. So that's how to use function decorators, and a taste of the sort of things we can use them for. In the next video, we'll look at another programmable syntax feature of Python that meshes nicely with function decorators.